Hi, and welcome back to AWS Julie. Today we are continuing our new series covering network fundamentals in AWS, and we will cover the fourth layer of the OSI model, Layer 4, the transport layer. Please remember to share this video with anyone who may be interested. Give it a thumbs up if you like it, sub if you love it, and let's dive in. So we're diving into the OSI model, and we're learning about Layer 4, the transport layer, which runs on top of the network layer, Layer 3. And runs the functionality to support the networking used on the internet. Remember, at Layer 3, the network layer, there is no reliable method of ensuring packet delivery, and packets often go missing or are delayed in their delivery from network conditions or issues. At Layer 3, every single packet is different, and it's single and isolated, and packets are a different unit of data being routed across Layer 3 using Layer 2 and Layer 1 for transit. So Layer 4, the transport layer, adds ports, error correction, retransmission, flow control, and a connection-oriented architecture. It also adds two new protocols, TCP, Transmission Control Protocol, and User Datagram Protocol, or UDP, and these run on top of the IP protocol in Layer 3. I'm sure you've seen the acronym TCP/IP. And that means TCP running on top of IP. TCP brings reliability, error correction, and the ordering of your data. It is slower than UDP, but it is reliable because it is a connection-oriented protocol. TCP creates a connection between two devices, and that creates a bidirectional channel for communication. UDP is faster because it does not have the same overhead as TCP for the reliable delivery of data. So it's faster but less reliable, and there is no guarantee of delivery with UDP. TCP and UDP both use the IP protocol in Layer 3 for transit. TCP introduces segments, which is another container for your data, just like packets for Layer 3 and frames for Layer 2. Segments are specific to TCP in Layer 4. Segments are actually contained and encapsulated within the IP packets. Segments do not have a source and destination IP address because they use the IP packet source and destination IP addresses. TCP segments add additional capabilities to the IP packets. And for the fundamentals, let's focus on a few, just like we did in a previous video. And up first, we have the source port. And this adds the ability of TCP and IP packets to have multiple streams of communication at the same time between two devices. And the destination port adds the same ability of TCP IP packets to have multiple streams of communication at the same time between the two devices. The sequence number is incremented with each segment that is sent, and it can be used for error correction because it is unique and can also ensure that when segments are received, the data can be pulled out in that correct order. The sequence number uniquely identifies segments within a connection, so both sides can observe using acknowledgement. And the acknowledgement field allows one side to acknowledge that it has received up to a certain sequence number. Each segment in TCP needs to be acknowledged because TCP, again, is a reliable protocol. The flags are used to choose the connection or to synchronize sequence number. Flags can be used to set the connection. So fin finishes the connection, ACK acknowledges the connection, and SYN synchronizes the sequence numbers. The window field, this defines the number of bytes the sender is willing to receive with the acknowledgements. This ensures flow control and lets the receiver control the rate at which the sender sends data. The checksum is used for error checking. The TCP level can detect errors and can also arrange for retransmission. And the urgent pointer helps with data transfer so that both sides have separate processing. These fields are known as the TCP header and are placed inside segments. And then outside of the header is the data. So let's also talk about how are segments used in TCP. So Layer 3 transmits packets, but there is no error checking, no ordering, and no associations of packet. Layer 4 takes the data given to it and breaks it into segments. The segments are then encapsulated into packets and contain a sequence number to ensure the segment is maintained. And if a packet is lost in transit, the segment can be retransmitted. Layer 4 ensures you can create a connection between the client and the server. TCP uses a three-way handshake. You cannot send data without first creating this connection to send data, and both sides have to agree on fields before the data can be sent and received. The client first creates a segment to inform the server of the sequence number it will start with to track and acknowledge the segment sent. So the send flag will be sent with a random number. Once sent, the server is aware of the sequence number the client will start with. Once received, the server creates a new segment of its own and sets the send and acknowledge flags and creates its own sequence number to start with and sends this back to the client. The client is now informed of the sequence number. Then the client will acknowledge this segment and creates a new segment to send back to confirm that the client understands the sequence number and acknowledges that, and now the connection is established and data can now be transmitted. Layer 4, the transport layer, adds ports, error correction, retransmission, flow control, and this connection-oriented architecture. It also adds two new protocols, TCP and UDP, that runs on top of the IP protocol at Layer 3. Now in the next lesson, we're going to dive deep into Layer 5, the session layer, and we're going to build on top of Layer 4. Thanks so much for stopping by, and I hope to see y'all again real soon.